Congrats for getting the correct answer. Looks like you have mastered this topic, but I will still explain on how to get the answer. So firstly, we need to identify the central atom, which is the least electronegative atom. Although in ammonium ion, hydrogen is the least electronegative atom, but hydrogen can never be the central atom. Thus, the nitrogen will become the central atom of ammonium ion. Secondly, we need to calculate the total number of valence electrons. In ammonium ions, there are 1 nitrogen atom and 4 hydrogen atoms. And for each nitrogen atom, we have 5 valence electrons, and for each hydrogen atoms, we have 1 valence electrons. So, the total number of valence electrons is now 9. And don't forget, for polar atomic ions, subtract 1 electrons for each positive charge because we release 1 electrons to form positive charge. So the total number of valence electrons is 5 plus 4 minus 1 equals to 8. The third step is to draw single bonds between nitrogen and hydrogen atoms. Before we draw the bonds, we need to arrange the position of the atoms first. In this case, the nitrogen is the central atom, so it will be located at the middle, and the hydrogen is terminal atom, so it will surround the central atom. And then we will then add bonds between the nitrogen and hydrogen atoms. And then after we add all the single bonds, we will find out that there is no more non-bonding electrons, and all of the electrons and all of the atom has reached stable octet electron configuration. So the simple Lewis structure is now completed. Don't forget to add up the bracket and charge after we draw the Lewis structure, because for ions we must draw the brackets and mention the charge. Westphal theory, which is also known as valence shell electron pair repulsion theory, states that the electron pairs in a valence shell surrounding a central atom repel one another. Thus, the bonding pair and the lone pair electron arrange themselves to be as far apart as possible to minimize the repulsion. This results in the lone pair repels another electron pairs more strongly than the bonding pair. The conclusion is the lone pair and lone pair repulsion force is higher than lone pair and bonding pair repulsion force, and the lone pair and bonding pair repulsion force is higher than bonding pair and bonding pair repulsion force. For us to determine the molecular geometry, we need to know the electron pair geometry first. The electron pair geometry is the arrangement of electron pairs about the central atom of a molecule or ion. So for example, if the central atom has 2 electron pairs, means the electron pair geometry is linear. And if the central atom contains of 3 electron pairs, the electron pair geometry is trigonal planar. And for 4 electron pairs, the electron pair geometry is tetrahedral, and 5 is trigonal bipyramidal, and for 6 is octahedral. And the electron pairs is the total number of bonding pair and lone pairs.
Now guess the electron pair geometry of CH4.